So on our previous video, and it cut on its own. I don't know what happened. I don't know if it was a message that popped up, so it had to cut on its own. So we ended by finding 390, right? Then over our summation of f, which is 20. So 390 divided by 20, we are finding 19.5. Okay, we are finding 19.5. So for us to find the variance now, we are going to subtract this one minus the square of our mean. So we are going to simply say variance is equal to 19.5 minus the square, right? The square of that mean. So this is our mean. So if we find, this is our mean. If we find its square, so just do this, all right? Which is 4.2 squared. What is 4.2 squared? We are finding 17.62. So minus 17.64. All right. Then what is 19? 19.5 minus 17.64. We are getting 1.86. So for variance, we have 1.86. So this is for variance. Now, when you are finding the standard deviation, we are just squaring that, right? If we square this now, that's our standard deviation, all right? And that's the one that they're asking for. So it's a square of 1.86. We are getting 1.36381817. Leaving our answer in 1 into dp, it is 1 point. Our standard deviation is equal to 1.36. That is our answer. That's how you get to find the standard deviation. So we have managed to score that 6 marks, right? That is our 6 marks there by calculating standard deviation. So in the next video, we're going to now interpret this, all right? You're going to interpret that. And we've been asked to show it on the sheet of graph paper. All right. So now we are on this part, right? So we are saying using the table above, copy and complete the relative cumulative frequency table below. All right. So now how do you get to find the relative cumulative frequency table? So how to find the relative cumulative frequency table? You get your frequency, the cumulative frequency, all right, over the summation of f. So our summation of f is 20. So what we are going to do is we are going to say 0 divided by 0, 0 divided by 20 is 0, hence that is 0 here, all right, hence that is 0. Then say 3 divided by 20, 3 divided by 20, 3 divided by 20, we are getting 0.15. 0.15. All right, that's the 0.15 that we have here. So let me just use the table instead. All right, so we have 0.15 after dividing that 3 out of 20. Then we say 6 divided by 20. So 6 out of 20, we have 0.3. All right, we have 0.3. Then we say 11 out of 20. Okay, oh yeah, 11 out of 20. 11 out of 20, we have 0.55. Then we say 17 out of 20. 17 out of 20, we have 0.85. So we indicate here 0.85. Then we say 19 out of 20. 19 out of 20, we have 0.95. 0.95. Then we have 20 out of 20, which is 1. Okay, now that we have finished the table, all right, now we have finished the table, which is part 1, all right, then we go to all right. So for part 2, we are saying that using a scale of 2 centimeters to represent 1 unit on the x-axis, so we have 0 all the way to 7, right? So in the x-axis, right, in the x-axis, we are talking about this part, all right. This is the part. So from 0 right here, from this to that, it's 2 centimeters. So if this is 2 centimeters, that means we have 1 unit here. All right, then we have 2 units, 3 unit, 4 unit, 5 unit, 6 unit, all the way to 7. So we can clearly indicate that 1, 2, 3, 4, 5, 6, 7. That is for x-axis. All right. All right. Then for y-axis now. For y-axis, we have been told that and 2 centimeter to represent 0.1 unit on the y-axis for 0. Y is greater or equal to 0, but less or equal to 1. So we'll start from 0. Then this 2 centimeter represents 0.1. So we're going to write 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and we have 1. All right. All right. And our mothers are hustling outside. They're buying the broken dishes. Okay, so now this is how you get to interpret that. Now that we have done that, now it's saying that draw a smooth relative cumulative frequency curve. All right, we need to draw the smooth relative cumulative frequency curve. So what we are going to do when drawing a curve, we are going to start, we are using this information which is representing our x and that. All right, so we have 1, comma 0. So 1 is right here and 0 is there. So we maintain the point to start from here. All right, then the point to start from here, because now on our table we have 1 and 0. Then we go to 2 and 0.15. 2 and 0.15. So we are going to where 2 is, yeah? Then we have 0.1 here. So 0.11, 0.12, 0.13, 0.14, 0.15. It's right here. Okay? Now that we have indicated that, we go to 3. And 3, we have 3 is 0.3. 3 in the x-axis, 0.3 in the y-axis. So we have 3 here, and 0.3 is here. 0.3 is right here. Okay? Then we come to 4. 4 and 0.55. 4 and 0.55. So 4 is right here. 0.5 is this one. 0.51, 0.52, 0.53, 0.54, 0.55. It's right here. Then we go to 5. 5 is 5.85. 5.85. So we have 5 right here all the way to 8. 5.81, 5.82, 5.83, 5.84, 5.85. It's right here. Then we go to 6, right? Yeah. We go to 6. 6 is 6.6 in the x-axis and 0.95 in the y-axis. So this is our 6 all the way to where 9 is. This is where our 9 is. So we say 9.95, 0.95, 0.91, 0.92, 0.93, 0.94, 0.95 right here. All right, then the last one, it is 7 and 1. Right, yeah, 7 in the x-axis and 1 in the y-axis somewhere here. Okay, so the next thing that we are going to do is to get to connect these now. So we'll start from here. All right, so our curve will come out like this. All right, that's how our curve, a relative cumulative curve will come out. All right, relative cumulative frequency curve will definitely come out like that, and that's how we get our 3 marks. And then let's get to answer the. All right, let's look at this question now. Under statistics, we're back on statistics. It's saying the following table shows the result obtained by 60 learners in a mathematics test. All right, so this table here is showing marks scored, right, from 0 to 10, then 10 to 20, 20 to 30, 30 to 40, 50 to 40 to 50, 50 to 60, 60 to 70, 70 to 80. All right. So we have 2, 6, 10, 15, 12, 8, 4, 3 as our frequency. That's the number of learners, right? So saying calculate the standard deviation. Calculate the standard deviation. First thing first, all right, how do we get to calculate the standard deviation? So what we are going to do is, right, we are going to say, let me put this, okay, we need to first find the mean. We need to first find the mean. How do we find the mean? We say x bar is equal to summation of f of x over summation of f. Okay, so by summation, what does that mean? We mean that we need to find now the sum of the multiplication of the frequency times the x. All right, the multiplication of the frequency and of the x. So we'll first write our frequency, because our frequency we have two. Okay, I don't know if you guys are able to see, but 2. Let me do this. Come on. All right, our frequency we have 2, 6, 10, 15, 12, 8, 4, 3. This is our frequency. 2, 6, 10, 15, 12, 8, 4, 3. So we are going to write those. So to be 2 open bracket plus 6 open bracket plus 10 open bracket plus 15 open bracket plus 12, okay, open bracket plus 8 open bracket. Am I going to have space? Plus 4 open bracket plus 3 open bracket. All right, that's what we're going to have. Okay, so after opening the brackets now, let me lower this up, down. After we open the brackets, what are we going to put now there? It's the x. So this x, since this is a grouped data, so this x will only be found by finding its midpoint. All right? The x will only be found by finding the midpoint. So the midpoint of 0 and 10 is 5, so we'll put 5 right there. Then the midpoint of 10 and 20, 10 plus 20 is 30. 30 divided by 2 is 15, we put 15 right there. Then the midpoint of 10 and 30 is 25. We'll put 25 right there. Then the midpoint of 30 and 40 is 70. 70 half of it is 35. Then the midpoint of 40 and 50 is 90. That we are going to have 45 there. Then the midpoint of 50 and 60 is 110. All right, so we are going to put 55 here. Then the midpoint of 60 and 70, we have 130. So we are going to put 65 right here. All right. Then 70 plus 80, we have 150. 150 divided by 2 is 70, 75. Over, all right, over the summation of f. So now, for summation of f, we're just getting this, because these are the ones that we have here. Down here, we're going to get a 2, say 2 plus 6 plus 10 plus 15 plus 12 plus 8 plus 4 plus 3. Or just getting that 60 that we have been given there. All right? So we just put 60 down here. Then after that, we get to enter this data, say x bar is equal to. We are going to add everything, all right? Everything. So to be 2 open bracket, 5 close bracket, all right, plus 6 open bracket, 15 close bracket, plus 10 open bracket, 25 close bracket, plus 15 open bracket, 20, is it 35 close bracket, plus 12 open bracket, 45 close bracket, plus 8 open bracket, 55 close bracket, plus 4 open bracket, that's 65 close bracket, plus 3 open bracket, 75 close bracket. Then say equals, we have 2,340 over 6. So get to divide by 60. Our answer, our mean is 39. That is our answer. Our mean is 39. So I found mean. Right, all right. Then let's answer the question that follows now. Saying answer, right? Answer this part of the question on a sheet of graph paper. So saying using the table below, copy and complete the cumulative frequency table below. So now do we get to find the cumulative frequency? So we started by saying 0 plus 2, it is that 2. Then this 2 plus 6, it's 8. 8 plus 10, it is 18. 18 plus 15 is 33. 33 plus 12 is 45. Then we say 45, all right? 45 plus 8 is, of course, 53. Then we put our 53 right here, 53. Then say 53 plus, okay, 53 plus 4, we have 57. And then 57 plus 3, it is 60. All right? So we have completed that table for part 1. All right? So now let's quickly interpolate this, then we come to the next video as we get to plot that. So I've been told that using a scale of 2 centimeters to represent 10 units on both axes. So from in our x-axis from 0 to 80, then in our y-axis from 0 to 60, draw the smooth cumulative frequency curve. Let's do that in the next video. Or before that, let's quickly interpret this because now that's the part. We have been told that in the x-axis, all right, from 0 to 80, so and we're taking 2 centimeters, representing 10 units. So 10, 20, 30, 40, 50, 60, 70, 80. So up to that point. Then in the y-axis is from 0 to 60, 10, 20, 30, 40, 50, 60, somewhere here. Okay, so we can simply connect these, all right? We can easily just do this. Then we bring this one right here. Like that. So this is our x-axis and this is our y-axis. All right, so we have 10, 20, 30, 40, 50, 60, 70, 80. So 10, 20, 30, 40, 50, 60, 70, 80. We have 10, 20, 30, 40, 50, 60. Okay, so my good friends, let's check out the next video as we get now to plot that curve. Right, number of learners and marks scored. So now let's plot this. So how are we going to plot? We are going to use the same table that we formulated here. So this on top are x-axis and this is for y. So we'll start from 0, 0 at this point. That's where our curve will start from. Then we say 10, 2. 10 is right here. 2 is 1, 2, somewhere here. Okay. Then we say 20, 8. 20, 8 is just 2 away from 10. 8, 9, 10. All right. Then we have 30, 18. 30, 18 is we almost call 2 away from 20, somewhere here. Then we have 40, 33. 40, 33. So 40 is right here, but 33 is up here. 30, 31, 32, 33. It's here. Okay. Then 50, 45. So 40 is here. 41, 42, 43, 44, 45. It's right here. 1, 2, 3, 4, 5. Good. Then we come to 60, 53. 60, 53. So we have 50, 51, 52, 53 is here. Okay. Then we say 70, 70 and 57. So we have 51, 52, 53, 54, 55, 56, 57 right here. Then 80 and 60. So 80 is right here, 60 is here. Then we are done connecting those dots. So we'll quickly do this. Okay, Okay. Right. So the curve will come out like this. The curve will come out like this. So this is the curve, and we have managed to draw the curve. Okay. The next thing from our question now is saying, using your method clearly, use your graph to estimate the interquartile range. Saying using your method clearly, use your graph to estimate interquartile range. Of course, we know interquartile range is upper quartile minus lower quartile, right? Yeah, so let's do that in the next. Okay, we can still accommodate in here. So, this is part what? Part 3. Okay? Okay, so we are going to say, for us to find Q1, okay, it says Q3 minus Q1. So how do we find first upper quartile? Right, how do we find upper quartile? So for us to find the upper quartile, right, is 3 of 4, or 3 out of 4 multiplied by the total of this, total number of the learners. So it's 3 over 4 multiplied by 60. Okay, so 3 over 4 is same as 3 divided by 4. Okay, 3 divided by 4, we are getting that, multiplied by 60. I think it's 45. Yeah, we get 45. So in our line, this line here, we go where 45 is. We count, we have 1, 40, 41, 42, 42, 43, 44, 45 is right here. So we draw a dotted line. We draw a dotted line. Pyong, 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 pyong. And down here, we have and pyong, 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 pyong. All right, pyong, pyong. It's at 50. So our Q3 is equal to 50. All right, it's equal to 50 scores, or 50%. Then we find Q1. How do we find Q1? It will be 1 out of 4 multiplied by 60. All right, 1 over 4 multiplied by 60. So say 1 over 4 multiplied by 60. We have 15. So we come where 15 is, that's our Q1. So we even indicate this one is our Q3. All right, so our Q1 is 15. So we count 1, 2, 3, 4, 5. We do the dotted again. 1, 2, pyong, pyong, like that. Then we bring it down like that. So we are finding something like we have 20, 21, 22, 23, 24, 25, 26, 27, 28. It's 28. So Q1 is, so it's indicate here Q1 is equal to 28. So for us to find now interquartile range, we are going to say Q3 minus Q1, which is 50 minus 28, which will give us 22. Okay? So our interquartile range is 22. If it was semi-quartile, so now we found the mean, right? We found the mean. So the next thing that we need to find now is the variance, which is denoted by this. So variance, you can find variance by saying summation of x squared, summation of fx squared over summation of f, which is the same as this. The only difference, because if you compare for mean and variance, but of course variance you get to subtract by the mean squared. All right. So if you look at this part alone, all right, the only difference is that our x is there, it's not squared, but this one has a square. So we can now use the same information. Now we are just putting square on our x. We put square, 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 like that. So then what we are going to do next is enter our data in our computer. So 2 open bracket, 5 squared, plus 6 open bracket, 15 squared, plus 10 open bracket, 25 squared, plus 15 open bracket, 35 squared, right, plus 12 open bracket, 45 squared, plus 8, open bracket, 55 squared, plus 4, open bracket, 65 squared, plus 3, open bracket, 75 squared. Then say equals. We get that. Then we divide by that same 60, all right? So we have 1,805, all right? 1,805. So this part we have found 1,805 minus, then the square of this one, right, was so to be 39 squared. 39 squared, you're having that, which is 1,521. So we are going to say 1,805, 1,805 minus 1,521. We are going to get that. So our variance is 284. So for us to find now the standard deviation, standard deviation is equal to, we just square the answer. So we can simply say square the answer, all right? We just square the answer. Whatever we find, that's our standard deviation. So we have 16.85229955. Leaving our answer into dp to be 16.85. That is our standard deviation. Okay, that's how you get to find the standard deviation. We have managed to answer this question.